discuss about very interesting topics, and that is the topic of sequence. Now, what is sequence? Let's consider a scientist doing the scientist or an observer or researcher who is doing an experiment. He or she is collecting data every day. Then let's U1, okay? Let's U1 be the data collected the first day, and let's U2 be the data collected on the second day. Okay, and also let U3 be the data that he or she collected on the third day. As you continue, as he will continue to collect the data, he will get NF term, and let's call that NF term, which represent a certain a number of terms that he will or she collect. The term is UN. So the number n is representing the number of days that he collects that information. Here we are generating a set of numbers with a very special characteristics. So there is an order in numbers, that is, we actually have the first number, the second number, and so on. Therefore, the definition of sequence is a set of numbers or set of real numbers with a natural order. Okay? Sequence is defined to be the set of real numbers. Real numbers with a natural order. Right. That is the definition of sequence. You see, first we have to collect the amount of information on the first day, and on the second day you have also another amount of of information. On third day we have also a certain information that we have collected in addition to the second one, and on a certain number of days we also collected the UN information. So as you see, the information, it is arranged in order. So this order is called sequence. Okay, so let's see another thing, that is arithmetic sequence. Arithmetic sequence. Yeah. So what you have to know about arithmetic sequence is that when the sequence has a constant difference between successive terms, it is called arithmetic sequence. It is always or sometimes abbreviated to BAP. That means arithmetic progression. Okay, progression means a sequence, the number of ways the thing goes around in order of the form. For example, we can say the number like 1, 3, 5, 7, and 9. Here you see we have first term that is called U1, which is equal to 1, And also according to the next number, we have the difference, which is equal to 3 minus 1, and this is equal to 2. So as you can see here, arithmetic progression or sequence is determined by first term, common difference, and the number of terms. So let's see how we can calculate the nth term of arithmetic progression. So first we have u1, the initial term. Okay. Secondly, we have this is the initial terms. Term. Yes. Secondly, we have u2, which is equal to initial term plus a common difference, and that is the second term. Okay. Thirdly, we have u1 plus d plus d, and that means it is u1 plus 2d, and that is represent third term. Okay. Fourth, we have u4, which is equal to u1 plus plus 2d plus d, and this represents a fourth term. So this will become u1 plus 3d. So as we see here, if we take a un, it will be equal to u1 plus n minus 1 times d, because this is the coefficient of different d. So as you can see here, this is n. Okay, here this is n, and here this is the coefficient of d. Okay, this is the coefficient of d. So as you can see here, n is differ by coefficient coefficient of d by 1. So that means since n is differ with the coefficient of d of different d by 1, and that means it is n minus 1. So this is the nth term of arithmetic progression. Nth term of arithmetic progression. Like un is equal to u1 plus n minus 1 times common difference. This is the nth term of arithmetic progression. Right. So we know that. Let me also discuss about a little bit about geometric progression. We know that un is given by u1 plus n minus 1d. Okay. So in this video I have u1. u1 is the same as a1. It's equal to a1. Yeah. So don't have confusion about this term that I am using. Also un will be the same like an. Okay. So don't be confused with this term. Okay. So if we replace if we replace n by n plus 1, so we will have un plus 1, which is equal to u1 plus n minus n plus 1, not minus, then minus 1 times d. Okay, so this will be u1 plus n times d. Therefore un plus 1 is equal to u1 plus nd, and so d will be calculated as d equal to u plus 1 and un plus 1 is the next term, which is next to un, then minus u1, which is the first term, over n. Okay, or also n can be calculated as un plus 1 minus u1 over common difference. Okay, we have seen that this is the common difference, okay, and this is the first term, and this is called the nth term, right? So secondly, let's discuss about sum of nth term of arithmetic progression, right? Okay, sum of an arithmetic progression can be obtained by multiplying the average of all the terms by the number of terms. So the average of the odd terms is equal to a plus un over 2. Then multiplying by number of terms, we will get Sn, which is equal to n, where n is the number of terms, times the average of all terms, that is a, where 8 is the first term, 8 is the first term, plus an. This is equal to an, and you can use any symbol here, then over 2, and this means Sn is equal to n over 2 a1 plus an. So here n is the nth term of AP. A1 is the initial term or first term of full arithmetic progression, and in saying un an, it is the nth term. It is the nth term. No, it's the number of terms. Yes, number of terms, and here it is the nth term of arithmetic progression, right? Therefore, as you can see here, sum of nth term equals to n over 2 a1 plus we have seen that an equals to a1 plus n minus 1 times d, where d is the common difference, and this is mean that Sn will be equal to n over 2a1, since this is equal to 2a1 then plus n minus 1 times common difference, and this is the sum of arithmetic progression. Let's also discuss about another important issue, and that is the geometric progression, which is denoted by GP, geometric progression. So what is geometric progression? A sequence is a geometric progression when a sequence has a constant ratio between successive terms. Okay? Let's see how this comes. Example, if we have 1, 2, 4, 8, 10, 12, here you see the common ratio is, that is what called arithmetic progression. So let's see a general expression for nth term of geometric progression. Sorry about that mistake. So nth term of geometric progression. Firstly, we have to consider let's say A1 be the first term. Okay, it is the first term. Then A2 will be equal to A times R, which is R is the common ratio. A3 will be equal to R power 2. A4, okay, will be equal to A1 times R power 3. Then A5 will be equal to A1 R power 4. So as you can see here, the nth or nth term of geometric progression can simply be equal to an, which is equal to a1 times r power negative 1, because at first term we have r power 0, then r power 0 equals to 1, and a1 times r power 0 equals to a1. Okay, since r power 0 equals to 1, okay, that's why. So, and also this is because at the first term we have no ratio, because it is the first term. So the second term we have this one, we have r power 1. So as you can see, it is differ by only 1. Okay, so because of this, we can conclude that the nth term of GP or arithmetic progression can be given by a1 r power n minus 1, where n it is the number of terms and the r it is the common ratio, and the a it is the first term. So this is the useful formula you can use anywhere when you are dealing with the geometric progression. So okay, number 2, let's also see the sum of nth term of geometric progression. So Sn will be equal to a1 plus a1 r power 1 plus a1 r power 2 plus a1 r power n minus 1. See, Okay. Then multiply both sides by r. We'll get rsn equals to a1r plus a1r power 2 plus a1r power 3 plus a1r power n minus 1, and also plus a1 power r power n. Okay, also let's discuss a little bit about sum of nth term of a geometric progression. We have seen that Sn is denoting the sum of nth term of geometric progression and is given by a1 plus a1 is the first term plus a1 times the second term, which is a1 times r plus a1 r power 2 the third term, a1 r power 3 the fourth term, then a1 plus times z factorization. We will say we have Sn1 minus r, which is equal to a1 minus r power n. Then Sn will be equal to a1 minus r power n, then over 1 minus r with r which is greater than 1. Also, if we take rsn minus sn will be equal to, okay, here we will have a r power n minus a. Okay, then by factorization we will have Sn times r minus 1, which is equal to a r power n minus 1, and Sn will be given by a times r power n minus 1 over r minus 1. This is only possible if and only if r is greater than 1. So this is the formula that we need to use when we are dealing with the sum of geometric progression. This condition should be fulfilled. Thank you for watching this video.